Hello, everybody. Welcome back. It's Mo again. Well, this lecture we're going to be looking at is access list. What does that mean? What is an access list? Well, I could make my router as a firewall. Remember, what is the job of the router? The router connects me from my LAN to the WAN. The router connects me from one LAN to another LAN, right? Another job of the router, I could make it as a DHCP server, right? What I could also do with the router is make it as a firewall by configuring an access list. In other words, the router is going to be filtering traffic. It's going to be permitting traffic. It's going to be denying traffic. That's what an access list is. For example, there's different types. So let me get myself a router. Here's a 1941 router, and I'm going to get myself a switch. And here's an actual switch. And let's say we get a few actual computers. Here's one, two, three, and four. So I have a few systems over here, as you see, and I have a few computers. And let me make the actual connection. Of course, straight through cable, all right? I could do automatically choose, but now we should know which cable should we use. Is it a straight through cable or is it a crossover cable? So let me connect this over here. And then the router will connect also to the switch. So I have how many broadcast domains? Just one. How many collision domains? Five. One, two, three, four, and five. Let's say at the moment it's five. Let's say I have another switch over here. All right. So let me get myself another switch and I'm going to put an actual server right over here. And I'm going to make a connection from the router, watch this, to the switch. And then, of course, I'll make a connection from the server to the switch itself. So, how many broadcast domains do we have now? One, two. How many collision domains? One, two, three, four, five, six, seven. Right? So, I have two different networks over here. I have a server here that can provide services such as HTTP, such as FTP, email, name it. Almost everything is actually on the server using the Cisco Packet Tracer. So what I want to look into first is when it comes up to access list, there's different types. We have a standard access list, we have an extended access list, and we also have a what? A named access list. So there is standard, extended. So watch this. We have a standard access list, right? And we have an extended access list, and each one operates a little bit different access list. And then we have a named. Named is not really another type, it's just an actual name instead of an actual number. So when I say a standard access list, if I go to the router and I go to my CLI, and let me just go ahead to global configuration mode. And let me ask for help over here. So if I put a question mark, I do see the access list command. Okay, so watch this access list, and I put a question mark. Okay, if I use a number from 1 through 99, that means I'm using a standard access list. If I use a number from 100 to 199, that means I'm using an extended access list. Well, how about a name? I go ahead and I type IP space question mark and I see access list and it gets a name. So now I could do a named access list, which is either standard or extended. So I will not consider a named another type. It's most likely standard or extended access list. Now, what is the difference? A standard access list filters only based on the source address, not the destination. An extended access list will filter based on source and based on destination. So it's more flexible. A standard access list cannot filter based on TCP and UDP ports. Well, an extended access list can filter based on TCP and UDP ports. So I'm more flexible to work with an extended access list. Now, one thing to understand about an access list, if I create a standard or let's say an extended, there's a few things that we need to know. Access list, they use wildcard masking. What is a wildcard masking? What's a wildcard masking? A wildcard is actually what? The inverse of the subnet mask. So this is the inverse, which is the opposite of the subnet mask. That's a wildcard. So for example, my subnet mask is 255.255.255.0 for class C. What is the wildcard? The 255 becomes a zero and the zero becomes a 255. Let's say I have a class B, which is without subnetting 255.0.0.0. What is the wildcard? Zero. dot zero dot 255 dot 255. That's a wild card, the inverse of the subnet mask. How about if I had a class A, 255.0.0.0? What is the wild card? Well, the 255 becomes a what? A zero, and the zero becomes a 255. So as you see, the actual wild card is the inverse of the subnet mask. And then we'll see what we can manipulate. This affects the entire network. So when I create an access list and I want to permit something or deny something, I have to specify the wild card, which is the inverse of the subnet mask. That's how access lists operate. And also, there's other routing protocols that operate on that, which is EIGRP and OSPF. So it is something that we need to know. Now, one thing I need to understand about the access list, watch this, once you create an access list, there is an implicit, and we'll be showing you that through a lab, deny at the end of the statement. Now, what do we mean by that? So if I say I'm going to permit a specific host or permit a specific network and I don't do anything, it's going to deny everybody else. All right. So that's one thing to actually know. Access lists are read from top to bottom, which means it reads it from the top to the actual bottom itself. So, for example, I say I permit a specific host, then I deny something, then I permit. There's no such thing as deny overrides allow. It reads the statement from top to bottom, and we'll show you that. All right. Another thing, access lists will take effect. Will take effect once you apply them to either an interface. Well, so it has to be applied to interface. It could be applied to a line, like a line VTY, interface F00, interface gigabit 00, or let's say to a router, a router interface itself, which is a router protocol itself. So I have to apply it. Like, for example, if I'm using RIP, OSPF, EIGRP, and I want to filter traffic, which networks a specific router can see, I have to apply it to the router RIP. I have to apply it to the router OSPF or EIGRP. In this section, we're going to be looking at what? Interfaces and lines, right? We're not going to be involving routing protocols. But what I'm trying to say is you cannot just create an access list and leave it like there in the fly. Okay, for it to be effect and to be applied, I have to apply it to an interface or to a line. That's how it's going to take effect. And remember, there's always an implicit deny at the end of the statement. Another thing, access lists use what? A wildcard mask, right? That's what I wanted to do is just give you an intro of access list. In our next lecture, we're going to see how a standard access list works, and then we'll see extended, then we'll see named. I just want to let you know, like the requirements, what we need to actually know about access. So we'll see you folks in our next lecture. Bye now. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at is a standard access list. And I'm going to give you like a simple example first. So let me get myself a router. Here's a 1941 router. And let me get myself a switch. And let me get myself a few laptops. All right. Here's one, two, three, four, and five. So I do have a simple setup right over here. See that? So here's a router and here's a switch. Let me make my actual connections. Of course, all of them are using a straight through cable. So let's say this is port one, this is port two, port three, four, and five. I could use automatically generated, all right? And I could just plug it in. I like to know which ports I'm actually going to, and I like to use gigabit interface on the switch, not fast Ethernet, so I get the actual speed of 1 gigabit per second. All right, so I'm going to say that this network over here, which is the broadcast, I only have one broadcast, is 100.0/24. Okay, so that's what I have. And then I'm going to say, go to the router and say, what network am I going to be using? What IP I'm going to be configuring over here? Let me just change the actual computer name. Let's say host name R1, enable secret is Cisco, and then line VTY04, which means for the telnet, password is Cisco, right? So I'm just setting up the passwords itself. And then log in to activate the password. I'm going to make This router, I could make it as a DHCP server if I want, but I want to make the passwords encrypted, service password encryption, which means it's going to cipher all the passwords. And then I'm going to do WR as a C, just WR. I can make it as a DHCP server, IP DHCP, exclude the address, which is 100.254. That's going to be the IP of the router. And then I'll create a pool over here. Let's say 100, and my network is 100.0 space the default mask, and then the default router, which is the default gateway, 100.254. And let's say we're using Google for DNS. All right. Exit. Let me apply an IP address to the interface, gigabit 00, right? And here's the IP address, which is 100.254 space the default mask, dot zero. And of course, I need to do what? No shut. I need to turn on the interface. And how do we save? Do WR. All right. Control Z. Let me look at my actual configuration. So this one over here is what? I could see that I'm excluding this number. I could see the pool that I'm creating, right? And I could see that I have my gigabit and the interface is not shut down. And look at this. This is the telnet and the password's encrypted because I did the service password encryption command. If I didn't do this, I will know what the password is by looking right over here. All right. So what does that mean? Well, let me go to my actual machines and obtain an IP address automatically. So DHCP, and right over here, DHCP, right? All of them are getting an IP address, DHCP. All right. Instead of putting static numbers, I'm just putting DHCP, so it comes actually from the pool. And remember, DHCP is based on what? UDP ports, what? 67 and 68. And let me maneuver the mouse. This one got 100.1. This one got 100.2, 100.3, 100.4, and 100.5, which means I should be able to telnet into the router, which is called what? Router 1, right? So my router is called router 1. I like to also change it right over here to make things actually neat. So let's call this R1 as you see. Okay, so what does that mean? I don't have any access list. Let me just show you. There's no filtering. The router's not a firewall. So I could do show access list, and I see nothing. Okay, perfect. Well, let me go ahead and telnet into the router. Let's telnet 192.168.100.254. See that? I can get in. So I put the password, log in, enable secret. Now I'm in. I go to another one. All right. There's no filtering. I should be able to do it from all of them because I did VTY04. That means 5 people can telnet at the same time. This one works. I don't have to log in. Telnet 192.168.100.254. This one works, right? All of them are going to actually, what folks, work. Telnet. I only can have up to 500.254. This one works. And also, this one works. I don't have any filtering, right? There's no filtering at all. All right. So as you see, look what I'm going to do right now. Go back to the router and I'm going to configure an access list. First of all, I'm going to do a standard access list, which filters only based on the source address. And then we'll be looking at extended and then we'll see name. But watch this access list. If I use a number from 1 through 99, that means I'm using a what? A standard access list. I'm going to give it a number 10, then space question mark. Do I want to permit or do I want to deny? Let's say I want to do a permit. Okay. Question mark. Do I want to do an entire network or do I want to do everybody or a single host? I'm going to start with a single host. So I'm going to say host space question mark. What is the IP address of the host? 192.168.100.5 space question mark. I see the CR carriage return. That means I can press enter. Guess what? I'm not going to do anything else. You know what that means? It's going to deny everybody else, but the access list won't take effect until I link it to a line or an interface. So I'm going to go to line, VTY, 0 space 4. Then I ask for help. Oh, there you go. Access class. That's how I filter. Okay. Access class. What is the access list number? 10. Okay. And is it inbound or outbound? This is for inbound. So I'm going to say in and space question mark and press enter. Then I'm going to do WR. All right. So I'm actually saving my actual configuration at the moment. Then I'm going to look at show access list, and I could see that I'm permitting a specific host, which is 100.5. And guess what? It's going to deny everybody else. Okay, so watch this. So if I go back here and I say, let me exit out, all right, and let me go ahead and just what? Telnet into a specific router, failed. Let me tell it into the specific route itself, failed. This is 100.2. You see this? 100.3 failed, and 100.4 failed, and let's see 100.5, it will pass. There you go. So now this is actually passing. I can remote into the router because I specified the access list itself only permit who? 100.5. Remember, there's an implicit deny at the end of the statement. That's what I wanted to show you as a first example. Very simple one. We're going to be doing a lot of examples. So we'll see you folks in our next lecture. Bye now. Everybody, welcome back. It's Mo again. We're still looking at the same example as you see. But look what I'm going to do right now. I'm going to go back to the router and I'm going to say no access list. So I'm going to go to global configuration mode and say no access list and the access list number, which is 10. Now I'm going to go to the line VTY 04 and say no access what? Class 10 inbound. The reason why we did in because we're getting into the router, the traffic is not coming out of the router, is going in the router, then enter. And let me do WR. So now I don't have an access list. Watch this, as you see. So if I go back and just test it with one system, I should be able to get in. See that? That's the first laptop. So I should actually get in. All right, so watch this time. Fig T access list. I'm going to use the same number, 10. Okay. I'm going to say deny something specific. I want to make mistakes over here. I want to show you what kind of mistakes we could actually make. So let's say deny, for example, question mark, an entire network, which is 192.168.100.0 space question mark. What is a wildcard? Okay, the subnet mask is 255, 255, 255.0 for a class C. So the wildcard is the opposite. The 255 becomes a 0, 0.255, and press enter. Then I'm going to say access list 10, permit, let's say a specific host, and the host is going to be 192.168.100.3, right? Now there's going to be a what? An implicit deny at the end of this, which means everybody else is denied. I need to link it to a line or an interface. So I'm going to say line VTY 04 access class 10 for inbound traffic and enter. All right. Control Z. Let me save my configuration. Show access list. And look, it's denying the entire network, but then it says permit a specific host. So what do you think is going to happen? You're going to think that 100.3 is permitted, right? Watch this. Let me go back and show you something here. Where's 100.3? Is this one 100.3? Yes. Okay. No. Rejected. Of course, the other ones should be rejected. Everybody's rejected right now. Nobody will be able to connect. Let me just prove to you. I thought that 100.3 will be able to tell that. Let me exit out, all right, and tell it. No. Why? Because access lists are read from what? Remember? They're read from top to bottom. And then if I go back over here and I take a look at this, like, well, the first thing it says, deny the entire network. Who's 100.0? Everybody from 100.1 until 100.254. So 100.3 is part of the first statement. Well, how do I do this then? Okay, well, if I want to do this right, I would do config T, no access list 10, and I'd say line VTY. I like to do it the right way. No access class 10 in. Let me exit out and let's say access list 10. And I'm going to say what? First of all, let me go ahead and permit that specific host. So I'm going to permit a specific host. And who's that host? 100.3. And let me go ahead and do access list 10, deny the entire network, which is 100.0. Say 0.0.255. Then let me do the line VTY 04 access, right? Access class 10 in. Now 100.3 is permitted, then everybody else on the network is denied, then every other network is denied because of the implicit deny that we don't see at the end of the statement. And then let's say do WR. Control Z. show access list. There you go. See, it reads it from top to bottom. Let me go back to my actual machines and show you. So if I go to this one is going to be rejected. This one, of course, is rejected. Now, this one is going to work. There you go. I got the log on. All right. This one is rejected. And this one is rejected. See that? That's how you actually work with access. You have to specify the top first, and that's how it reads it to the what? To the actual bottom. Okay, let me go back and remove what I actually have over here. So let me go ahead and config team, no access list 10, then line VTY 0 space 4, no access class 10 in. So I got rid of everything, which means everybody should be able to what? To telnet in. So let me go back and take a look and see. So if I go back here, this one should telnet. See that? This one should telnet. This one was able to, right? This one should telnet, and this one should be able to telnet, right? So that's one thing to keep in mind. Let's say you do this. Let's say you're thinking about being very, very smart, and you say access list 10 permit a specific host 192.168.100.5. And then you say access list. Let me come up with another standard one, which is 1 through 99, 20, and let's say I want to permit another specific host, which is 192.168.100 dot what? Let's say 100.4. All right. Then I have two access lists right now. So if I do show access list, I have to use a do command, remember? So I could see I do have 10 and I do have 20. Oh, nice. We're very smart over here. Okay, well, how about now? Let's see how smart you are when you do line VTY04 and you say access class, I want to apply 10 in, and then I want to apply 20 in. Okay, let's see what's going to happen. Okay, Control Z, WR, show access list. Sorry, show access list. I can see access list 10 permitting 100.5 and everybody else is denied. Then access list 20 permitting 100.4 and everybody else is denied. If I do show run, watch this. Oh, only one takes effect. You cannot apply more than one access list per line per interface. Like one can be for inbound and a different one can be for outbound. Okay. So the 20 took over, which means 100.4 is the only one that is going to be actually connecting. Where's 100.4? Right over here. Okay, let me try this again. Okay, good. Where's 100.5? Right over here. This one is going to fail. Okay. So one thing to actually understand, you only can have one access list for inbound and one access list. It could be a different one for outbound. So don't be thinking you could manipulate the router the way you actually want. All right. That's what I wanted to show you in this actual example. I want to show you something different. So remember, only, let me put this here, only one access list can be applied to inbound, inbound traffic, and a different one. You could be using the same one, but then you could have a different one, right? A different one for outbound, for outbound traffic, right? You cannot have two different ones applied for inbound and two different ones for what? Outbounds. So that's one thing to keep in mind. Another example that I wanted to show you. I want to put static IPs, and you'll see why. Let's say this one is 192.168.100.1, which is whatever it was. And this one is going to be 100.10. All right, 100.10. All right. This one is 100 let's say 30, 100.30, and let's say 100.40, 192.168, 100.40, and this one is 100.50. And you'll see why am I actually doing this? 100.50. So look at this. I have 100.1, 100.10, 100.20, 100, like, okay, this is 10. What is this one over here? This is 40, 50, right? Is this 50? Yes. And this one over here is what? As you see, 30. That's fine. So 100.1 and look, different numbers. Why? Watch this. Let me go back to my router and do, first of all, config T, right? So global configuration mode, no access list 10 and no access list 20. All right. Then let me go to the line VTY04, no access class, let's say 20 in, because remember the 20 took over. So I believe right now we got rid of everything. So if I look at my configuration, scroll run, right? Do I see anything about access list or anything applied? No, I'm actually good, which means everybody should be able to connect. Let me just try this one more time. Can this one connect? All right. So I'm going to try and connect. Yes. Can this one connect? Everybody can connect right now. Remember, I changed the numbers and this one can connect. Let me just verify. This one can connect. Everybody can actually connect. All right. And this one can connect. And this one can actually connect. There you go. This one is not connecting. Oh, I typed something wrong. Okay, there we go. All right. So everybody can connect. Watch this. I'm going to go back and do the following right now. I gave you a good example, and I gave you like a very simple one. Access list 10. And I'm going to say permit the network 192.168.100.0 space the wildcard. What is the wildcard? Well, guess what, folks? Look what I want to show you over here. I want to show you some increments. You remember the binaries? I could have what? 128, 64, 32, 16, 8, 4, 2, 1, right? So normally when I have a subnet mask as 255, 255, 255.0, the wildcard is 000.255. This applies to the entire network as 192.168.100.0 slash 24. The entire network is getting affected, right? So the entire network is getting affected by this. Watch this. Let's say if I do 192.168.100.0, but then the wild card is going to be different. Remember, I cannot touch the first three octets because this is a network. I can manipulate the host. Watch this. Well, this one is the number 4. This is the number 8. I'm going to focus on these 16 and 32. These are the ones I could manipulate with. All right. So watch this. If I say my wild card is 000, I know it's a class C. Okay. I'm not going to put a 255. I'm going to put the number 3. What does that mean? And then I'm going to do 000, the number what? 7. Then I'm going to do 000, the number what? 15. Then 000, then the number 31. 3, 7, 15, 31. So you always look at what? These are the increment numbers they can manipulate. 1 minus the increment number is the wild card. You see that? 1 minus 8 is 7. 1 minus 16 is 15. 1 minus 32 is what? Is 31. So no longer I want to do 000.255. I want to focus on these numbers over here. Why do I want to focus on these numbers over here? Watch this. If I go ahead back to my Cisco packet tracer and let me open the router, all right? And I say 000.3. Then I do a line, which means everybody else is denied, but who's taking effect over here? Line VTY, 0 space 4, access list 10 for inbound traffic. Okay, if I say 100.0 and my wild card is a 3, which means my jump start is a 4, who is going to be permitted? Okay, let's take a look and see. Let me do Control C, show access list. See that? Look, I'm permitting this entire network. Wildcard says 3. Okay, what does that mean? Let's see, and you'll understand. So if I go to this machine, can I telnet? Yes, I can telnet. If I go to this machine, can I telnet? No, you can't. Why? What's the IP address of this machine? 100.10. Okay, this one, there's no way. And this one, there's no way. None of them can connect. And this one cannot, right? And this one cannot. See that? Why? Okay, if I give this number 100.2, watch this, 100.2, and I give this number 100.3, watch this, 100.3. You'll see why I'm changing them. And I give this one 100.4, watch this, 100.4. See that? That's why I made them 40. And this one 100.5, like the way I was before dynamically. And let's say 100.5. Close this out. Okay, can 100.2 connect? Let's see. 100.2? Yes, it can. Can 100.3 connect? All right, let's see. Yes, it can. Can 100.4 connect? Let's see. Oops, it cannot. 100.5, oops, it cannot. I'm going to say oops before. It cannot. So 100.1, 100.2, and 100.3 can connect. Why did 100.4 and 5 didn't connect? Because I go back over here. My wild card is a what? A 3, which means it's 100.0, and the wild card is a 3, which means the increment number is a 4, which means it's going to allow 0, 1, 2, and 3. All right. Four numbers. So it's going to allow 0, which is an network ID, which doesn't make sense. So IP address 100.1, IP address 100.2, and IP address 100.3 will be permitted. IP address 100.4 and 5 will not be permitted because they're not within the range. So the jump start is a 4, which means this goes from 0 and add 4. 0 is 1, then 1, then 2, then 3. Only up to 100.3. For example, let me show you another example. I'm going to go to config T and say no access list 10. All right. Then I'm going to say access list 10 permit the network 100.0 space 000.7 this time. Okay. What is 7? 7 increment number is 8. So if I did 100.0 over here, let me go back here. 100.0. This allows 0, 1, 2, 3, 4, 5, 6, 7. From 0 through 7, let's say, is allowed to telnet into the router. 0 through 7. Okay? Let me prove that. This is what? Let's say I'm going to make this one as 8 to prove a point. 100.8. I'm going to make this one 7. Okay? And I'm going to make this one as 6. Right? So 6 is the number. 6, 7, and 8 are the numbers that are allowed, but 8 will not connect. And I'm going to leave this as it is. So 2, and I got what over here? 6, and I got over here what? 7, and I got over here 8. Okay, let me go back and try. Okay, this works. This one is what? 100.1. This one again, so you can see 100.2. This one is going to work. How about this one? It's going to work. And this one is 100 dot what? 7. Watch this. It's going to work. See that? But look at 100.8. Watch this. It's not going to work. Why? It's allowing 0 through 7. Okay. So if I don't want to do the entire, I could use different wildcards. For example, let me go back and change this. Watch this. No access list 10. And then I say, if you notice, I didn't get rid of the line because it's the same access list number, so it's fine. 10. And let's say permit 192.168.100.0 space 000 dot what? 15, which means the jump start is what? 16. This permits what? Yes, from 0 through 15. Okay, let's take a look and see. Okay, I'm going to show you more and more examples, so no worries. So I'm going to make this one as 16. Okay, so this one is going to be 16. This one is going to be, let's say, 15. These are the only ones I'm going to change. And this one, I'm going to leave it as what? Is this one 6? Yes. And this one is what? This one is 2. And this one is what? 1. Okay, let me open, connect again. This works. Let me connect again. This works. Let me connect again. This one works. Perfect. Let me connect over here. Let's see. Connect again. Works. And this one should fail. So this one is going to fail for us. See that? So when I said I'm allowing from 0 through the number 15. All right. You see that? It's very simple. The jump start is what? Is 16. Right. So that's why you need to know these increment numbers. So if I want to do 31, show you my last example in this lecture. So I'm going to say no, access list 10. And let's say access list 10. And let's say permit 192.168.100.0 space 000 dot what? 31. What does that mean? It's going to allow from 0 to what? To 31. Okay, I'm starting with a 0 here. You'll see more and more examples, no worries. So from 0 to 31. Let me go back and let's say this one is going to be what? Yes, 32. See this? This is 32. So if I connect from here, this one is allowed. I didn't change these numbers. This one is allowed. This one is allowed. Right? This one is allowed. And this one should be what? Denied. There you go. Okay. That's what I want to show you in this lecture. In our next lecture, we're going to do a different example for a standard access list. And then I'm going to show you more and more about these increment numbers. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to do is we're going to continue with more and more access lists. We're still working with the standard. I actually got rid of the access list, so I don't have any access list at all. Let me just log on. All right. And let me show you. Show access list. I have nothing. Show run. I actually also removed it from my what? From my VTY, which is a telnet. Watch this. If I do config T, and let's say access list 10, and I say permit somebody specific, so I'm going to permit. And this time, look what I'm going to do. 192.168.100 at what? I'm not going to start with a 0. All right. I'm going to start with an 8. And then I say 0.0.0. What? 7. What does that mean? And I'm going to press enter. And I'm going to do a line VTY04 access class 10 for inbound traffic. So when I say 100.8, and the increment number is what? 8, because 1 minus the increment number is the wild card. So let's see, does this affect from 8 to 15? Is 8 through 15 permitted? That's what I want to see. So I'm going to go back to here. And let's say, what numbers do I have over here? Let's say this one is what? I'm going to make this one 16. Close this. And I'm going to make this one 15. It's already 15. All right. And what is this one over here? This one is 6. And how about this one over here? This one is 2. And this one is 1. All right. Let me open the command prompt. Telnet. I cannot telnet. Why? 100.1 cannot telnet. Okay. 100.2. Can it telnet? No. Let's see why. What is this one? 100.6. Telnet? No. Okay. Let's see this one over here. 100.15. Can it telnet? Yes. 100.15 is the only one that was able to telnet. Why? Well, check this out. This one is what? 15. This one is what? Watch this. 16. So my access list was saying what over here? It's allowing from the number 8 to the number 15. Okay, let me prove a point over here. Let me change this one over here. Instead of 6, I'm going to make it 8. See this? 8. Let me try. So let me go ahead to the command prompt and try again. This one can. Okay, if this one is 9, this one cannot, right? Okay, this one could. Why? Because this one is 15. What if I make this one? Let me see. This one is failing. And if I make this one as, let's say, 9, or even, let's say, 7, 7 is not going to work. I like to save and close and just do that. And I cannot. You see, so now this is actually allowing what? From the number 8 plus 7 is 15. So from 8 to 15 is permitted. Okay, let me exit out and show you another example over here. So let's say no access list. Let me go back to global configuration mode. No access list 10. Enter. Then access list 10. And I'm going to say permit. And I'm going to specify an actual network over here, right? I want to permit a specific network 192.168.100 dot what? Let's say 100 dot starting with 32. All right. So 100.32. And this time I do 0.0.0.31. What does that mean? 32 plus 31 is what? 63, right? So this allows from 32 to 63. I permit, there's an implicit deny. Everybody else is what? Denied. So from 32 to 63 is actually allowed. Okay. So I'm going to make this one as, let's say, 31. Okay. And this one as, let's say, 40. All right. So you can see. And this one as 50. And this one as 63. Okay, 63. And this one as 64. Just like this. Close this and close this. Now, remember, if I go back to my actual router, it shows me I'm allowed from 32 to 63. All right. What is this one over here? This one is 31. This one should what? Yes, it should fail. 32 to 63 only. This is 40. It should pass. There you go. This one over here is 50. It should pass, right? And this one over here is what? 63. It should pass. See that? And this one over here is what? 64. It should what? Fail. See that? Just like this. Okay, how about this? I do have a range over here, right? I do have a range from 32 to 63 is allowed. I'm going to do no, access list 10, and I'm going to say access list 10, deny a host, which is just 40, 100.40. Then I'm going to say access list 10, permit 192.168, 100.32, space 000 dot what? 31, which means the 40, okay, host, I did 4. You guys didn't say anything. So I'm denying a specific host 4, and 4 is already denied. So I want to do no. This is a problem with numbers. Look what happens. I have to remove everything. You see, named access list. I don't have this trouble. Okay, let's do this again. Access list 10, deny a specific host 192.168, 100.40. And then I say access list 10, permit the entire network that starts with 32 up to what? 63, 31. I don't have to do anything else. The line is already there, right? So 40 is denied. Did I have a 40 over here? Was there a 40? This is a 40. Okay. Denied. You see that? Remember, it reads it from top to bottom. Denied. This one was denied from before because it's before the number 32. This one is what? 50. Yes, we're good. This one is what? 63. Yes, we're good. And this one over here is what? This one should be denied. 64. It's denied. That's good. All right. That's what I wanted to show you. Okay, let me show you another example. So let me say no access list 10. Okay? Access list 10, let's say permit 192.168.100.16. And let's say you do 000.3. All right. This is what you do. So now you're telling me that you're going from 16 to what, 19. So if I start with 16, does it mean I have to have 15 over here? Well, 16 has increments of 4. The wild card here is a 4. So does this mean that 16, 17, 18, and 19 is allowed? Let's see if this is correct or not. 16, 17, 18, and 19. What is this one? I'm going to make this one as 16. And I'm going to make this one as 18, let's say. All right. So this one is 18. And this one is what? 19. Okay. Let me close this out. And this one over here is, let's say, 20. And this one is, let's say, let's take a look, 31. I'm going to make this one as 31. And you'll see why I'm actually doing this. Okay. Going back to my actual router itself, look what I see. So 16, you're going to tell me this, that 16 plus 4 is what? 4 numbers, which includes 16. So 16, 17, 18, 19 is permitted. So if I go back here, this one is what? 16. Okay. Let me tell it. Okay. Allowed. Good. What is this number? 18. Okay, let's see. Allowed, yes. Okay, this one is 19. Allowed, yes. Okay, how about this one? What is this one? This one is 20. Let's see if it's allowed. No, it's not. How about this one? 30 what? What did I make it? 31, right? All right. And not allowed. What does that mean? What I'm trying to say is the following. My jump start is a 4, is not a 16. What I did over here on purpose to show you that I am starting with the number 16, but my increment number is 4. So this allows from 16 through what? Through 19. So 16 plus this, 32 plus this. You see, that's how you actually get it. That's what I wanted to show you in this lecture. In our next lecture, we're still going to be looking at a standard access list. I'm going to give you a different example where we apply it to an actual interface instead of a line. So we'll see you folks in our next lecture. Bye. Everybody, welcome back. It's Mo again. Well, in this lecture, we're going to look at is another example of a standard access list. I'm going to open a new one. But let's say you wanted to save. You could have done like file over here, save as, and you put it on your desktop. You give it a name so you could load it back later. It's good to have templates, as you see. So I'm going to open a new one. I'm not going to save. So I'm going to get myself router. Here's a 1941 router. All right. And I'm going to get two switches. One switch over here and one switch over here. And I'm going to get an actual server right over here. And I'm going to go ahead and get some clients right over here on the bottom switch. So let's say two laptops, one, two. And let me make my actual connections. So let's say the laptop is hooked up, of course, to the switch, port one, port two, and the server is hooked up also to the switch. Let's say port one. The router, gigabit 00 will hooked up to the bottom, and gigabit 01 is hooked up to where? To the top one. See that? Just like this. So that's what I have over here. Now, what I want to do is, how many broadcast domains do we have here? We have one, two broadcast domains. How many collision domains? One, two, three, four, five. All right. This side is 192.168.100.0/24. And this side is 192.168.200.0/24. So I have 100.0 and I have what? 200.0. Let me go to the router and configure the router first. So I'm going to click on No and global configuration mode. I like to change the host name. You know what I like to do also? No IP domain lookup. If I don't do this command, let's say I type something that doesn't exist, I have to wait unless I do Control Shift 6. So what I like to do is every time I practice, I like to do no IP, sorry, no IP domain dash what lookup. Now, when I do a Control Z and I do ZZZZ, it's like, oh, I'm not going to look for it if it doesn't exist on the iOS. All right. So global configuration mode, interface gigabit 0/0, IP address is 100.254, space the default mask, which is .0. And then I do a no shut, which means turns the interface on, and I do a gigabit 01. I'm just hitting the up arrow, hit the up arrow, moving the mouse to the arrow to what? 200, and doing a no shut command over here. Then exit out. So this is actually fine. I'm going to give this a number. This is on the 200 network. So this will be 200 dot, let's say 200. I need the default gateway, which is the IP address of the router, 200.254. I don't care about DNS. I'm going to give this one 100.1, or let's say 100.100. And default gateway is the IP address of the router, which is 100.254. I don't need DNS. And this one will be 100.200, let's say. I'm just putting static numbers. I only have a few machines, as you see, folks. So 100.200, and I need the default gateway, which is 100.254. So I have 100.200, and the gateway is 100.254, right? So this is one network, and this one over here is a different network, two different broadcast domains. Here's an actual server. I mean, can I actually reach the server? You know what? I like to test it with ping because with standard access list, I cannot filter what, like TCP or EDP ports. So let's say this is 200.200. So if I open the command prompt and I say ping, I like to use a negative T, which is 200.200. The first packet will be actually lost, so no worries. It always happens. So it's going to reply. There you go. The reply is called ICMP. And I want to see if this one can ping 192.168.200.200. See that? So now everything looks fine over here. I don't have any access list at all. So I'm going to go to the router. This is my router one, right? Watch this. So router one, I'm going to open the interface itself and I'm going to say access list standard, which is 1 through 99, 10. And I'm going to say go ahead and permit a specific host. Let's say permit host 192.168.100.100 space question mark and enter. So I'm only permitting this specific host, right? I mean, but where? I'm not doing a line like my previous examples, right? Like telnet. No, I'm going to go to interface. The interface that is here, which is gigabit 01. If I'm not sure, I could go to options, folks, preferences, and show port label. and close this out. And I can see this is gigabit zero one. So I'm going to go back to minimize what I see on the screen. So I'm going to go ahead and get rid of the show port label. So this is gigabit zero one. So I'm going to go to gigabit zero one. Watch this 0/1. And I'm going to do the command, which is the IP command. I have to start with the IP command itself. There's no access list here. So IP space question mark. And I have the access group, which is for the access list. What is the access list number? 10. And for what? This time, I'm not doing inbound traffic. Is going to go through the router to me, which means it's coming from the out interface. So this time is going to be out. Okay. On enter. Now, I'm going to go ahead and do WR, save my configuration. What does this do for me? Well, let me do show access list and see. I can see that access is number 10, and I'm permitting a host which is 100.100, right? That's what I'm actually permitting over here. Who's 100.100? This one right over here. Okay. Command prompt, still pinging. This looks fine. Okay. Let's go over here, command prompt, and let's see over here if I can ping. I want to do it with a negative T. Remember it was pinging before? Negative T, space, question mark. And look, destination host unreachable. This machine cannot reach that server because it's going through the out interface of the router. That's where the in and the out are actually different. All right. So I just wanted to show you an example of out the way I actually did an example of what? Of inbound. So this is only one that can actually pass through the server. Because when I send a request, the server has a gateway, has to come through out this interface to here. And this one is denied. Only this one is permitted. So I had to apply it out on this interface itself. That's what I wanted to show you in this example of a standard access list. In our next lecture, we're going to be looking at extended access list, which is more and more configuration and more fun. So we'll see you folks in our next lecture. Bye. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at this extended access list. So far, we looked at the standard ones. So let's take a look. Extended filters based on source and destination IP address. And also, it filters based on what? TCP and UDP ports. So watch this. Let me get myself a router and let me get two switches. So let's say there's a switch up here, all right, and a switch right there. Let me get two actual servers, one here and one here. And let me get a few client machines. One, two, three, let's say four. So let me move this up a little bit so we have things organized in a better way. Remember, you could always increase the fonts, right, on your Cisco packet tracer. So if I go to options, preferences, the font, this is what I actually have, all right? And of course, I can see the port labels themselves. Let me just go ahead and hook up the cables. Of course, we have straight through cables. Let's say port one, port two, port three, and port four. And then I'm going to also connect the servers to the switch. So here it is, and here, the one connection here. The router, gigabit zero zero, will go down to the switch, and gigabit zero one will hook up to this switch right over here. So if we want to count, how many broadcast domains do we actually have over here, right? We have one, two broadcast domains. How many collision domains? One, two, three, four, five, six, seven, eight. All right, eight collision domains. I'm going to say that this is going to be on the 192.168.200 network. And this one's going to be on the 192.168.100 network. I'm going to put static numbers because we're going to be manipulating numbers, all right? So let me first go to my router, and let's say this is my main router, router one. And let me just open the router, CLI, of course, and go to the command line. Let me just first change my host name. So let's say host name is R1, right? And let's say enable secret is Cisco, and I want to encrypt the passwords, right? And I want to set up, let's say, a console, good for security. Password is Cisco, and then log in, right? And let's say line VTY 04, 5 telnet connections, and activate the password. And let me go ahead and put an IP address on gigabit zero zero. And what is the IP address? 192.168.100.254 space the default mask. And of course, I do a no shut command. And I go ahead and I do interface gigabit 0/1 and the IP here. I'm just hitting the up arrow, which is 200.254, and I'm doing the no shut command. If I do Control Z, let me just save my configuration. If I do show IP interface brief, sorry, interface brief, I can actually see my interfaces and they're actually up and running. If I do show access list, I have nothing. This server here, which is server 0, I'm going to give it an IP address. This is going to be on the 200 network. Let's say 200.100. And what is the gateway? The IP address of the router, which is 200.254. And this server is going to be 200.200. 192.168.200.200. And the gateway is 200.254. Then I'm going to close this and close this. This one is going to be 100.1. All right, so this one is going to be 192.168.100.1, and the gateway is 100.254. And I'm going to make this one as 100.2, right? And the gateway is 100.254. And this one is 100, let's say dot 3, and the gateway is 100.254. And this one is 100.4, and the gateway is 100.254. So that's what I have over here. Well, without an access list, each one of these servers has services such as what? HTTP, HTTPS, and it also has what? FTP, email. See, everything is actually turned on. Same thing on this server over here. This has all these services: HTTP, it has DNS, it has email, it has FTP, as you see, right? So if I go to this machine and I say, let me open the web browser and connect to one of my actual servers, right, which is HTTP colon slash slash, and I'll put 192.168.100.100. Is it 100.100? All right, it's what? 200.100. And let me connect. It works. Okay. Can I do HTTPS from here? Web browser. I could do all traffic. Everything is open. I could ping FTP, HTTP, HTTPS. I could do every single thing. HTTPS. Let's try the other server. 192.168.200.200. And it works. I open this one and I go to the command prompt and I say ping 192.168.200.200. It works. All right. I go to this machine and I open the command prompt and I say FTP space 192.168.200.100. And it works. Right. Everything is open. Okay. So what I want to do is this. Let me go back to the router. And I'm going to go to global configuration mode. Now I'm going to say access list. This time is going to be extended. So I'm going to use 100. And watch this. Permit or deny. I'm going to say permit first. All right. Watch this. And look, this is based on ports, TCP, UDP, ICMP, routing protocols. I mean, it's more flexible. All right. So this is more flexible. And I'm going to say ICMP, which is for ping. And then I'm going to say who's the source address. I could say any. I'm going to say any. And destination is what? Well, let's say any. All right. Destination is any. And I'm going to say the ping, which is the echo, just like this space, question mark, enter. That's what I'm going to do here. I need to apply this to an interface gigabit 0/0. And the command is what? Let me ask for help. And I'm going to use the IP command. IP space question mark, right? Access group access group. What is the access list number? 100 for inbound or outbound. Inbound and enter. I'm going to do Control Z, WR, and show access list. And I can see access list number 100. It's permitting the ping from anywhere to anywhere. But guess what? There's an implicit deny. I'm going to get denied for every other traffic, for every other protocol. I'm not going to be able to do HTTP, HTTPS, FTP, DNS, email, nothing. The only thing that is going to work is ping. Watch this. Let me see if I could ping anywhere on the destination because I said any. So let me go back over here and I'm going to say ping 192.168.200.100. Okay, I could reach it. Can I ping 200.200? I should be able to reach it. And if I go to the other machines, can I reach 200.200? Yes. Control C, 200.100. Yes, I could ping. And right over here, if I try to ping, let me just stop this. If I try to ping 200.100, I could. So 200 works and 200.100 should work. I could reach from everywhere. Okay, but if I try to close this out and go to the web browser and put the IP address of one of the actual what servers, let's say 192.168.200.100. Look what's going to happen. It's going to time out. I'll come back to this. All right. And let me just close this out and open the web browser. I'm just trying HTTP and HTTPS, and it's going to fail because there's an implicit deny for every other protocol for every other network. So here I'm going to do HTTPS colon slash slash 192.168.200.200. And look, this one is going to time out. And this one is also going to what? Time out. Let me try FTP. Can I FTP into one of the servers? Of course not. 200.200, I cannot FTP because there's an implicit deny at the end of each statement, right? Let's make sure it's going to actually fail. And there you go. It actually failed. And this one actually failed. So when I look at this access list and I take a look at it and I say show access list, well, I'm permitting only the ping to go from any source to any destination. You see that? That's an example of an extended access list. So it filters based on source destination, and there's always an implicit deny at the end of each statement. That's what I wanted to show you in this lecture. We're going to do more and more examples. We'll see you folks in our next lecture for more fun of extended access lists. So we'll see you folks soon. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to do more and more examples of an extended access list. I'm going to still use the same topology. So I'm going to go back and get rid of the access list. So I'm going to say no access list 100. All right. Then I'm going to go to the interface gigabit 00 and no IP access group 100 in. So now everything is back to normal, which means if I go back to this machine and I say click on go, immediately it opens. You see that? I come down over here and I FTP immediately opens, and I come over here and immediately opens. Everything looks smooth. So that's without an access list. So I'm going to go back to the router. Watch this. I'm going to go to global configuration mode and I'm going to say access list, let's say 100. And this time I'm going to do the same thing, permit, but watch this. I'm going to say, I'm going to do another example of ICMP, permit ICMP. Then I'm going to put a question mark. Source address, I'm going to specify a specific host. So I'm going to say host, all right? And what's that address? 100.3 space. What is the destination? I'm going to say any server. Space, question mark. What is it? It's ping, which means the echo. The reply from the ping is actually called echo. Then I'm going to say access list 100, deny, right? Put a question mark, ICMP from anywhere to destination anywhere, which is the echo, just like this. Space, question mark, and press enter. Then I'm going to say access list. Watch this. 100, deny. Okay, this time I'm going to be using a protocol, which is TCP. All right, which means what I'm trying to deny is something based on port what? TCP. Source address, I'm going to say any. Destination address is what? What is the destination address? I could specify a specific machine, and I'm going to say, I'm going to put a number this time, and you'll see why. Instead of host spaced IP address, I'm going to put 200.200. When you put a number without an actual, what, the word host, you still have to put a wildcard. And what is the wildcard? All zeros. You see this? Just show you something new. All zeros. So 192.168.200.200 space 0.0.0.0 is the same thing as me putting host space the IP address space question mark. What port? Equal to what? EQ. Then there's greater than. Then there's lower than. Then not equal. Then there's a range of ports. There's a bunch of things. So I'm going to say EQ equal to port what? 80. I'm going to deny anybody from connecting to this server through what? Through HTTP, and I'm going to press enter. Then I'm going to do access list 100, permit IP, watch this, any source to any destination, which means every other traffic is permitted. Because if I don't do this command, everything else is what? Denied. Then I'm going to do interface, gigabit 0/0. And I'm going to do IP access group 100 for inbound traffic. Control Z, WR, show access list. And now I'm permitting ping to come from 100.3 to ping everywhere. Everybody else is denied to ping. Let's test this first. All right. And look, port 80 changed to what? www. Okay. Let me see if 100.3 can actually ping everywhere. Where's 100.3? This is 100.3. Can this one ping 200.100? Yes. And this one ping 200.200? Yes. You see one, which is dot one, dot two, and dot four should not. So let me go back over here, close this out, open the command prompt, and see if this one can ping. And look, unreachable. You see this? I cannot reach 200.200, and I cannot reach 200.100. Unreachable. Okay, now I go to this device over here, and I try to ping. 200.200, unreachable. Because I said deny everybody else. See, it reads it from top to bottom. So I did it the right way. Then 200 dot what? Dot 100 is denied. Okay, how about this one over here? When I close this out and I go to the command prompt and I say, let me try and ping. Ping 192.168.200.200. And look, destination host unreachable and 200.100 destination host unreachable. So I cannot actually reach those. Why? Because look at this. I go back to the router. It tells me I'm only permitting this host from reaching anywhere, but then I'm denying everybody else from reaching ping. And then what happens? I'm denying TCP port 80. Any person, any person that connects from the source to this destination. So nobody can connect to HTTP on what 200.200. Let's see. So here, 200.200 should fail. Watch this. 200.100 should work. 192.168, 200.200. This one should fail. Again, I try. 200.200 should actually fail. All right, which is the regular HTTP. So this one is 200.200, and this one should also fail. All right, let's see. And this one should fail because I said block port 80. That's how I block a port on a router, which is through an actual access list. So let me do 200.200 on this machine also as well. And this one should also, let me just click on it. There you go. 200.200 should fail. And also this one. Let me just verify, right? For the fun of it. And this one should also fail. 200.200. It takes a while. I like it. It's like you're actually dealing with a real computer. All right. Remember, now I'm making my router as a firewall because it's filtering packets. What's in the packet? Source and destination IP address. And I'm going to put over here 200.200. 200.200. It's going to fail. Look, failed, failed, failed too. Okay, let me go ahead and change this to 100. Passed, because I only specified one destination. Passed, perfect. Okay, how about here? Passed, perfect. Nice. Okay, and how about over here? It passed 200.100. Perfect. Okay, good. So if I go back over here, I just tested this one over here. Then it permits every other track, which means I could do HTTPS everywhere. I could do FTP. So if I open the command prompt and I try to do FTP in any server, it should actually work. All right. So FTP 192.168.200.200 should work. FTP on this one, even though this one failed on the ping, it doesn't mean if you cannot ping something, you cannot FTP. All right. So I know that this actually failed. I cannot actually ping. Which IP is this one? Is this 1.3? Yes, this one is the one that passed. This one should fail for the ping. Remember, this one failed for the ping, but it could still do FTP. So this one should also do what? FTP, FTP 192.168.200.200. It works. If I go to this machine and I say, I know that 200.200 failed, for HTTP. But HTTPS is open. I never blocked HTTPS. So HTTPS is kind of actually open for any actual server. So I'm going to give this a moment until it fails. There you go. So I'm going to put an S. Now it works. So my access list works properly based on the configuration that I actually have. So we're going to be doing more examples. So we'll see you folks in our next lecture for more and more extended access list. Bye now. Hello, everybody. Welcome back. It's Mo again. In this lecture, we're going to do another example of an extended access list. Let me get rid of what I have over here. So let me go back to the actual router. And I'm going to say global configuration mode, no access list, then what? 100. And then I'm going to go to the interface gigabit 0/0, and I'm going to say no IP access group 100 for inbound traffic. So that's what I actually have over here. Right now, there is no access list. That means all the traffic is allowed. So I'm going to say show access list. I have nothing. Okay, let me go back to global configuration mode. And let me do access list 100 question mark. And let's say, for example, first, I want to do the following. I want to say permit, right? And let's say TCP space question mark. And let's say source address is any. We saw how we could do this. Destination is any, right? Question mark. We could say EQ, which is actually equal to a port number. If I say greater than, which means more than one port, I could use a range of ports. So if I say range, all right, and I could specify the port number starting with port 80 space question mark, and then I'm going to say up to what? 442. So 80 to 442. That's what I have over here, and I'm going to press enter. So this affects the ranges of these ports. It's actually permitting ports 80 to port 442. That's the actual range that is actually what allowed. All right. So this is fine. Permit TCP from, and then I'm going to say, and there's always an implicit deny at the end of the statement. So I'm going to apply this to an interface, gigabit 00, IP access group 100 in, just like that. Okay, so what I do right now is I want to see if I could connect to port 80 and higher, 80 to 442. So I will not be able to reach 443, right? So watch this. So can this one connect to the web? Let me close this out and then the web browser. And let me go ahead and put the actual IP address itself. Let's see how this actually works out for us. So I should be able to put 192.168 200 dot, let's say 200. I could connect 200.100. I should be able to connect. If I go to this machine and I try to do FTP, watch this, which is port 21, 200.100. No, you can't. You're not in the range from 80 to 442. So everything else is denied. I'm only permitting from ports 80 to 442. See that? It's not working. So let me go ahead and open the web browser over here. Give this a moment and try to connect through what? HTTPS. I want to see if I could reach HTTPS. That's what I want to see. So now over here, I put HTTPS / 192.168.200.200. It's not going to work because I set from 80 to 442. Only those port ranges can actually work. Anything lower than 80 is not going to work. Anything higher than 442 is not going to work. That's what I want to show you here. Let me go back and show you the options that you can do. So I'm going to say no IP access group 100 in. Okay, then exit. Then I'm going to say no access list 100. I got rid of it. Okay, this time I don't have any access list. So if I go back to my actual machine that failed for the FTP, I should be able to FTP. There you go. All right. And the machine that actually failed for connecting to what? To HTTPS. Which one was it? Let me see. Was it this one? HTTPS? Or was it another one? This one. This one should work immediately. You see that? Nice. Okay, let me go back over here and do access list 100 this time. I'm going to do permit because there's always an implicit deny, question mark, and I'm going to still use TCP. So if the port was based on UDP, I would put UDP. And then question mark source, I'm going to say a specific, let's say source, which is host space 192.168.100.3. If I put host space 192.168.100.3, it's the same thing as me putting 192.168.100.3 space 0000. Destination is any, right? And then I'm going to say what? Not not the range. I'm going to say greater than GT. Anything that is greater than port 80 is permitted. Then enter. If I do LT, which is lower than, GT is greater than that actual port, then I'm going to say access list, right? 100, and I'm going to say permit, let's say TCP, and this time I'm going to be putting the entire network, which is 192.168.100.0. The wildcard is 00255. Destination is any, and I'm going to do greater than what? So I'm permitting everything greater than what? A specific port over here. Let's say, for example, I could put port 443. So this is only permitting this. Okay, so this machine can go over port what? 80 itself. But this one is going to go over port what? Let's say 21. Now I'm going to press enter. And then there's an implicit deny at the end of the statement. So then I'm going to do interface gigabit 0/0, and I'm going to do the IP access group 100 in, and I'm going to press enter. And then there you go, show access list. Now I could see I'm permitting a specific host, which is 100.3, to what? To connect to any destination that is greater than port what? 80. Let's try this. Greater than port 80. That means 100.3 cannot do FTP. Where's 100.3? Right over here. So I'm going to close this out. And this one should fail on the FTP. All right. Watch this. Let me stop this and FTP. It's going to fail. Okay. It could do 80 and higher. That means I can, let me just make sure it fails. So this is fine. Then I'm going to go to the web browser, right? And I'm going to put the actual IP address in the list itself. So let's give this a moment. And here I'm going to put 192.168.200.200. And now this works. Okay. How about if I do HTTPS, right? :/ 200.100. It's going to work. So if I click on go, it's going to open up. Why? Because this one says what? Anything that is greater than port 80, but I was not able to do port what? 21, which is FTP. The rest of the computers can do FTP and higher, which means this one can do FTP and higher. So it can do everything that what the other one did, but port 21 and higher. So if I go to the command prompt and I say FTP, watch this. So I say FTP space 192.168 and I say 200.200. This one, let's see if it actually works. Give it a moment, and I'll show you what's happening over here. So, okay, it says cannot. Okay, can I do FTP 200.100? I want to show you what you think is right and what you think it's wrong, even though it says FTP, folks. Watch this. Let me try another computer. So I only did 100.3. So the rest of the networks, if I try FTP over here, Control C and FTP, it's not working. Why? Let's troubleshoot. Okay, permit this host 100.3 greater than port 80. This is greater than port what? FTP. My source is 100.0, so it's permitting everybody, right, to any destination that is greater than this. Am I missing anything? Is there something that I'm actually missing? Let me take a look and see. Let me reverse this and see what's going to happen. What port did I do? I said port what? 21. Okay. Can we actually test something else over here? I said port 20. Okay, can I do port 80? Let's troubleshoot. Let me go back and see. Can I open the web browser? Right? 200 dot what? 100. Let's say web browser. And I'm gonna put 200.100 and see how this actually works. So let's give it a moment. Give it a few seconds. And 192.168.200.100. I could connect. So why the FTP is not doing so? Well, let me show you. Let me go back and show you a few things over here. I'm going to do config T. I'm going to undo what I did, and you'll see why. No access list 100. Then I'm going to say access list, let's say 100, permit, TCP, host, exactly what I did before. And I'm just copying what I see, folks. 100.3, space destination is any, and I'm going to do GT, and I'm going to do port 80. Then I'm going to say access list 100 permit, right? And who am I going to be permitting? TCP. And after I permit TCP, who am I actually permitting? 192.168.100.0.000.255. See this? That's what I'm doing over here. 0.255 space. I'm going to do any, then greater than port what? 20. It's already applied to the interface. The only difference is I did 21 before and now I did what? 20. Okay, let's go back and take a look. Can I do FTP right now? Command prompt, and let me try FTP. Now it works. Why? FTP is based on ports 20 and 21. So make sure you know FTP is not just 21. You better start with port 20. I did this example on purpose so you could see why it did not actually work. That's what I wanted to show you in this lecture. We're going to continue with more extended access lists in our next lecture. So we'll see you folks soon. Bye now. All right. Hello, everybody. Welcome back. It's Mo again. In this lecture, we're going to look at another example of an extended access list. Watch this. Let me just go ahead and log on to my router. So if I do show access list, I see nothing. If I do show run, I still have access list 100, integrated into what? It's affecting port 00. I'm not going to remove that because I'm going to use the same access list number. So I'm going to do config T access list. Let's say 100. This is a very good example. And whenever you have a web server, you don't want anybody to be actually pinging the server itself. You only want to allow port what? 443. So this is good security for an actual web server. And let's say, do I want to deny? Yes, deny. And what do I want to deny? Or I could say permit what I want. Then it always denies every traffic. So there's different ways to actually do this. But look what I'm going to do here. I'm going to actually go ahead and deny ICMP. There's no reason why you should ping a web server from any source to any destination. And I'm going to say the echo. See this? Just like that. Then I'm going to say access list 100 permit TCP. The more you do this, the more you get no, okay, what's the next command? I'm going to say equal to what? 443. I'm denying ping. I'm allowing 443. Then there's an implicit deny at the end of the statement, which is the only thing that works is 443. Control C, WR, save my configuration, show run. I have the access list linked to gigabit 00. Then I specified I'm denying ping. I'm only permitting this and everything else is denied. Let's test it. So if I go over here and I try to ping, right, one of the servers, let's say ping, doesn't work. Okay, how about ping 200.100? Doesn't work from any machine. Okay, but then I say, let me open the web browser and try and do HTTP because I'm looking for security. I don't want anybody to connect through port 80. I want all the connections to be port 443. So watch this 192.168.200.200. This is going to fail. You see this? This is port 80. So I'm only permitting port 443. That's what you should do for an actual web server that is hosting a website. Okay, then I'm going to put an HTTPS and now it works. See that? Just like that. This is like the best security approach whenever you're hosting an actual web server. And most likely today, everything is based on an SSL certificate. That's what I wanted to show you for extended access lists. In our next section, we're going to look at a named access list and see how that actually works out for us. So we'll see you folks in our next lecture. Bye now. Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at this a named access list. So watch this. I already have a router, so I have two networks: 100.254 for the bottom and 200.254 for the gigabit 01. I just have a server over here, which is 200.200. One laptop is 100.100, and as you see, I have the gateway, and the other laptop is 100.200. So that's the configuration. I have basic stuff. There's no access list at all. So what I'm going to do right now is if I do the following command, show access list, nothing. Named access list is show IP access list. Now, what is a named access list? It's either standard or extended, but it gets a name instead of a number. Watch this. Very simple. So I'm going to do IP space access list. That's how you create a named access list. Now I have to specify, is it standard or extended? I'm going to say this is standard. The name is no underscore, let's say telnet. All right, just like this. Then I ask for help, put a question mark, sequence number, like the order of the lines that will actually take effect. I'm not going to use that. I'm going to say deny a specific host, which is 192.168.100.100. Then I'm going to say deny what? Any. I mean, permit any. So there's always an implicit deny. So I'm just denying one specific host. Then I'm permitting everybody else. Now I need to apply it to what? To the line, right? Line VTY 0 space 4 IP access class. Is it IP access class? Let me ask for help. There's an access class. There's no IP access class. So this is access class. And what is the name? It's called no underscore telnet space question mark for inbound traffic and enter. That's all. So if I do show access list, it shows me the access list number, which is no telnet. And see the order 1020, so I don't have to use a sequence number. If I do show IP access list, it also shows me because this is based on named access list. Let me test it. Let me do WR, save my configuration, go to this machine over here and try and telnet into the router, which is 100.254. So telnet 192.168.100.254, and this is refused. Okay, let me go to the other one, which is 100.200, which is actually permitted, 192.168.100.254. This one is allowed. You see that? So when I go back over here, I can see that this is denied. So it gets a name instead of a number. It could either be standard or extended. Okay, watch this. Let me create an extended one. Config T, IP, access list, and I'm going to do extended. Okay, now the name over here, let's say no underscore HTTP. Okay, then space question mark, I could press enter. So when I put a question mark, I get more options. Watch this. So I'm going to deny question mark TCP, all right, space question mark. What is the source address? I'm going to put the single number, which is 100.100, and I have to use a wildcard as all zeros. And destination is what? Let's say any. I mean, I only have one, which is host 192.168.200.200. That's my destination. Space question mark. Which port? EQ, and I'm going to specify port what? 80. Then I'm going to say permit TCP, all right? The entire network, let's say 100.0 space. Let's assume we have a lot of numbers. Wildcard is the default. Space, what is the destination? I only have one host, all right? Which is 200.200 EQ, right? Let's say I want to allow port 80, let's say, for example. Then I don't do anything. That means there's an actual implicit deny. But then I have to come out of here and I'm going to go to interface gigabit 0/0. And I'm going to do what? Let me ask for help. Is there an access? No, I have to use the IP command, IP space question mark, and I'm going to specify access group. What is the name? No what? Let's take a look and see what I have over here. What did I call it? No HTTP underscore HTTP, right? So I put an underscore there, HTTP space question mark for inbound traffic. That's all. All right. Let me save my configuration and show access list, and I could actually see that. See, it puts www there. So let me check 100.100. It should not do HTTP to the actual server. Where's 100.100? Right over here. So if I close this out, I open the web browser, and let's take a look and see if we could reach 200.200. And look at this, it's going to fail. So let's give this a moment. Let's make sure it times out. And then we'll see that this one is going to be able to connect. Watch this, web browser. And everything else is denied because there's an implicit deny at the end of the statement. And this one is 100, right? Dot 200. So I'm going to connect to 200.200, and this time it works. See, as you see, a named access list is either standard or extended. It just doesn't get a number. It gets an actual name, so I'm not limited to how many numbers I actually have, right? So that's just a named access list. I'd rather deal with a number. I rather choose, okay, this is standard or extended. That's what I wanted to show you in this lecture. We'll see you guys in our next lecture. Bye now.